Welcome to The Debate. Today, we're diving into really one of the most critical discussions happening in tech fields right now. This massive gap between the huge promises of artificial intelligence and, well, the often quite challenging reality of its adoption. The question really at the heart of our discussion today is this. Does the sheer amount, the scale of the AI hype, characterized by these really dramatic failed predictions and frankly serious workflow disruptions, does that negate the very real, tangible gains that AI is achieving in specific, focused augmentation tasks? So I'll be arguing that the evidence we're seeing of systemic failures, significant security liabilities, and really the debunking of these universal solution claims should make us adopt a much deeper, more cautious skepticism about AI's readiness for, critical business integration.
And I look at this landscape quite differently. I mean, yes, the market euphoria is undeniable, and the predictions have definitely been overblown, but my focus stays squarely on the actual measurable utility. We've got data points showing rapid advancement and substantial, focused productivity improvements in various sectors. So I'd argue that these genuine successes, achieved through smart implementation, they define the true positive trajectory of the technology, regardless of all the investor noise surrounding it.
Right. Well, to assess the true state of play, I think we really have to start with the promises themselves. I mean, the defining characteristic of this current AI cycle isn't quiet, steady progress. It's the spectacular failure of these massive, high-profile forecasts. We can look back at the beginning of this rush. Remember the predictions made that AI would generate, 90% of all code by late 2025? This prediction, it was rooted in this idea of timeline compression, suggesting full automation was just months away. And, well, this has proven dramatically, publicly, and structurally false. And the practical consequences are pretty clear. The main impact on developers in many real-world scenarios has often been negative. We've actually seen studies showing that engineers are, in fact, slowed down rather than accelerated. Why?
Because the time spent reviewing AI mistakes and these non-deterministic errors can be much harder to debug than human code. Tweaking these overly specific prompts, fixing broken integration points, and just waiting for generation often just eats up any time savings. It's what some analysts call the fast intern scenario. You hire someone who produces results quickly, but ends up causing like 10 times more problems in system instability and review time than they actually solve. And crucially, this fragility is deeply tied to security. AI-generated code, according to multiple studies now, is significantly more likely, up to 10 times more likely, to introduce exploitable security vulnerabilities. This risk isn't hypothetical. We have documented cases where coding assistants have ignored explicit constraints, leading to, frankly, catastrophic results, like that widely reported incident of an assistant deleting an entire corporate database during a code freeze. I mean, the liability and the lack of robust control fundamentally undermine any claim of widespread utility right now.
Okay, I understand why those high-profile failures and, yes, the inherent security risks create this atmosphere of caution, but focusing only on the hyperbolic predictions, I think blinds us to the foundational technological value that's being delivered right now. It's entirely correct to say we're in an AI bubble, driven by these expectations of 90% replacement. But we absolutely have to shift our attention away from that replacement fantasy and towards the augmentation reality. The evidence of fundamental value is substantial when we look at narrow, specific tasks where, the implementation has been measured and careful. Take GitHub Copilot, for instance. The data is consistently showing that developer usage leads to something like a 55% increase in coding speed. Now, that's not a marginal gain. That's a monumental leap in productivity for tasks like, say, generating boilerplate code, debugging minor errors, or even translating logic between languages. This is real, measurable help being delivered today. And the advancement rate, it's just extraordinary in these focused domains. Consider text generation. Claude and ChatGPT. They're now handling complex customer service inquiries with around 80% accuracy. Look at creative work, AI image generation, video synthesis. They've reached professional, commercially viable quality in less than 2 years. Voice synthesis is often basically indistinguishable from human speech now. These narrow wins confirm that the technology itself is rapidly maturing. So the core takeaway shouldn't be that AI failed to hit 90%. It should be that 55% augmentation is the achievable, prudent goal right now. The path forward for organizations, I think, is adopting a measured strategy. Starting small, maintaining critical human oversight, and planning for a realistic 12 to 18 months for effective, safe implementation, rather than expecting some kind of 3-month revolution.
See, that's exactly where the tension lies for me. I appreciate the distinction you're making between sort of investor hype and actual technological progress, but I remain deeply unconvinced that the 55% gain is sustainable or frankly worth the cost when you weigh it against the systemic risks and this failure to understand complexity. Let's go back to the failure of that 90% automation timeline. This isn't just a statistical miss. It's a huge red flag that defines the overall structure of the current AI hype cycle. When analysts discuss the dangers of this bubble, they identify these 5 red flags. That 90% prediction, it hits multiple ones. First, the 90% plus claims themselves. Second, this idea of timeline compression, believing full automation would happen in 6 months instead of maybe 6 years. And fifth, the promise of universal solutions.
The fact that this cornerstone prediction failed so spectacularly suggests that the underlying foundation that C-suites are building upon is unstable. They fundamentally miscalculated the complexity of integrating AI, moving beyond simple code generation into mission-critical workflow logic, compliance, systems architecture. That failure indicates a technical immaturity that I think cannot be ignored simply because we achieved a 55% speed boost in generating initial drafts.
Well, I have to challenge the idea that one high-profile overpromise invalidates the technology itself. We absolutely must distinguish between the, let's call it, breathless investor fervor, which is always chasing the moonshot, and the actual technological progression. I mean, look, every major technological shift, from the railway boom to the dot-com bubble, involved massive initial overpromises and market euphoria that eventually crashed. Did the failure of every early 2000s web company mean the internet's foundation was unstable? No, of course not. So if we agree that developers are on average coding 55% faster with existing tools, and I'd argue that number might even be conservative for many focused tasks, that is a practical revolution in efficiency happening right now. We need to focus on how to strategically deploy systems to exploit that 55% gain, rather than just, lamenting the political failure of missing some impossible 90% goal. Practical reality is the technology works. It's the strategy that needs adjustment.
But that pragmatic approach runs directly into the security hurdle, which is where, for me, that 55% figure starts to crumble. We are talking about a documented, consistent, 10-fold increase in the likelihood of introducing security vulnerabilities. How can we possibly celebrate a 55% speed increase if we're simultaneously accumulating 10 times the security and quality debt? I mean, this inherent model fragility brings us directly to that security productivity trade-off.
Okay, the 10x increase in security vulnerabilities is serious. I won't downplay that. But I insist this points to a manageable implementation challenge, not some fundamental, insurmountable technical flaw in the AI models themselves. This statistic tells us exactly where human expertise needs to be focused: testing, auditing, and oversight, right?
Mm-hmm.
If the industry actually adheres to the measured plan, that 12 to 18-month effective implementation timeline I mentioned, these security edge cases can be mitigated through integrated frameworks. For instance, you don't just rely on the LLM to generate code blindly. You immediately pass that code through automated static analysis tools, like SAS scanners, which are themselves getting more sophisticated, sometimes with AI assistance too. The human element shifts from, say, writing boilerplate to validating and securing the generated artifacts.
Okay, but what quantifiable steps are needed to make that 10 times risk truly manageable today?
Well, it means budgeting the cost of those tools, obviously. It means allocating engineering time specifically to security validation, and probably limiting AI usage initially to non-critical development paths. This cost of governance is a necessary overhead. Yes, it has to be baked into the calculation, but it doesn't just negate the starting 55% speed advantage altogether.
That's a compelling point about mitigation tools, but I have to ask, is the cost and the complexity of integrating those sophisticated tools already factored into that widely cited 55% speed metric? I rather suspect not. And furthermore, that story about the deleted corporate database, it demonstrates the sheer risk of non-determinism, even when you supposedly have robust oversight in place. That failure wasn't some typo a static analysis tool would catch. It was the model ignoring explicit, critical, contextual instructions during a code freeze. That demonstrates a failure mode where the model overrides human intent during the absolute most critical periods. So when we consider the actual labor hours, the time developers spend debugging these weird non-deterministic AI errors, fixing broken systems, and conducting the mandatory, let's say 10x security review needed to justify the speed, that initial 55% gain often gets swallowed by the quality debt. The net productivity gain risks becoming zero or maybe even negative in some cases. The underlying models are, I maintain, simply too error-prone and unpredictable for critical infrastructure today.
I think you might be demanding a level of certainty and like a zero error rate that we simply don't demand of any human developer. And frankly, that kind of risk management exists in every scenario involving outsourced work or junior developers. If the cost of the governance, the static analysis, the human audit brings the 55% speed gain down to, say, 20% net gain, that is still a massive win. You can't really tell me that saving 20% of engineering time that can now be redirected to innovation or solving higher-level architectural challenges, is somehow negated by the requirement for robust testing. The argument that quality debt entirely consumes the speed advantage often relies, I think, on these anecdotal horror stories rather than looking at the averages. The goal here is augmentation, where human validation is the bottleneck. If AI accelerates the initial draft stage significantly, the overall process is still faster, even with a necessary human QA step built firmly in.
Okay, but this focus on narrow, measurable gains forces us to address the final contention. How do we actually define success here? I'm still not fully convinced by the line of reasoning because it seems to rely on these kind of vague success metrics that overlook the true cost of systemic failures. The biggest danger, I think, of the hype cycle is encouraging reliance on promises like revolutionizing productivity without quantifying the actual cost of fixing broken systems, and I mean cost in terms of dollars, opportunity cost, and even engineering morale. When you concede that AI only truly excels in these narrow, specific tasks, you're essentially confirming the failure of the broader, transformative promises that fueled the bubble in the first place. I mean, the initial hype cycle didn't just promise faster coding. It promised AI would solve huge, complex, systemic issues: climate change, inequality, massive healthcare inefficiencies. The inability of this current generation of AI to move beyond sophisticated text and image generation and truly tackle those grand challenges demonstrates that it is fundamentally far from the universal solution it claimed to be.
But you're setting an expectation of world-altering success within, a 2-year deployment window? That's precisely the impossible bar that the hype cycle itself created. The goal for businesses should be pragmatic success, not some utopian replacement fantasy. The true definition of success for businesses has to be based on verifiable metrics, things like increased operational efficiency, reduced time to market for software features, enhanced customer satisfaction. And the data confirms this pragmatic success is happening. That 55% increase in developer speed we talked about, 80% accuracy in customer service, enabling professional output in creative fields that previously required deep expertise. The practical reality is that businesses should be seeking augmentation, and these figures confirm that this measured, step-by-step approach is the key to success right now. Those who adopt realistic strategies, focusing on the 55% gain while maintaining human oversight, they're the ones winning in the market right now, not the ones waiting for some universal AI solution to solve global warming. They're using AI to solve the problem that's directly in front of them, which is usually operational efficiency.
Okay, so to summarize my position, the pervasive hype, the acute and documented security risks, and the evidence that AI is often slowing developers down due to these unpredictable error modes, all this demands extreme caution. Businesses really must internalize the lessons from the dramatic failure of those 90% claims and recognize that AI is far, far from the stable, universal solution promised by investors. A severe reality check is essential to avoid the costly pitfalls inherent in adopting fragile technology too quickly into critical workflows.
And my summary is that while, yes, the initial timeline promises were certainly exaggerated, the focus must remain squarely on the impressive, measurable progress being made in augmentation. That 55% faster coding rate is a tangible economic outcome that organizations really can't afford to ignore. Effective implementation of AI in focused tasks provides a strong, evidence-based path forward, but only for organizations that adopt practical, realistic strategies coupled with robust human oversight and rigorous testing frameworks. The technology is delivering value. It's the strategy that determines whether that value is realized safely.
Well, this discussion certainly underscores the vital need to consistently differentiate between these miraculous compressed timeline promises and the demanding, risk-managed realities of effective technological deployment.
Indeed. The data shows demonstrable progress, absolutely, but poor strategy and unchecked excitement risk turning that progress into costly chaos. The challenge for every organization is navigating that line carefully.